Hello everyone. In this lecture we can see about link state routing. So link state routing is considered as another important routing method we have in networking. So what is meant by link state routing? So link state routing is a method whereby we can able to find the least cost path from the source node to the destination, and for that we can able to apply this technique. And this link state routing has many advantage, so that we can able to send the data very fast from the sender to the receiver. So now we can see about link state routing and its features. So link state routing is a technique in which each router share the knowledge of its neighborhood with every other router in the network. So after collecting the data from the neighbors, the individual node will start to update its own table, and based on its updation, every node will come to know that by forwarding the data to which node they can easily able to reach the destination. So 3 keys to understand when learning the link state routing method. Knowledge about the neighborhood. So instead of sending its routing table, every router will be they will send the information about its neighbor. So a router broadcasts its identities and cost of the directly attached link to the neighbors. So once this information is collected, then it will be easy for all the individual node or the routers to make their updations. So the process of sending this routing table to the neighbors, it is called a flooding. So each router sends the information to every other router on the internet network except its neighbors, and this process is called a flooding. And here what you have to look on is, so every router that receives this packet sends the copy to all of its neighbors, and once every router receives the copy, they will start to update its own routing table. So thus we are sharing the information. So a router sends the information to every other router only when the change occurs in the information. So the shortest path to the neighbors, that data already if it has, then there is no need to update. But if there is a chance to update this table, then it will update the table. So now we need to focus on how we can able to form the least cost tree. So in the link state routing, based on the lowest link, based on the link value and its edge cost, we can say about how we can able to form the link in directing data packets. So now this database is called as link state database. The collection of states for all the links is called a link state database. Here you can able to view, this is one vector graph, this is one weighted graph for the network. So here we can see about 7 nodes are available, and 7 nodes are connected, thus it formed a weighted graph for the network. And for this network, if you want to build a database table, and this database table is called a link state database. Here the main part is the available all node values that will be written horizontally and vertically, and after that it's a table that is from A to the same node the value will be 0, from A to B the cost will be 2, from A to C it is unknown because infinity there are many pathway to reach node C from A. So only the directly connected nodes will be given the value, and the remaining all will be noted as infinity. So keeping this basic information from the link state database, every node will try to implement the linked state concept. And every node normally will be having a linked state packet. So the linked state packet, it will be having the neighbor router and its cast value. So when a node receives an LSP from one of its interface, it compares the LSP with the copy it may already have, and if the newly arrived LSP is older than the one it has, it will discard it, otherwise it will copy the data. So thus, after getting the data from every LSP, here you can see that this every node are actually possessed by the linked state packet. So linked state packet, for example, if for the node B, the linked state packet can be written as node 1 column cast. So B to A, the cast value is 2. B to C, the cast value is 5. Then B to E, the cast value is 4. So which were all the directly connected nodes for that everything. Here we are assigning this linked state packet, and after having this LSP data, we can able to further build the linked state database. So how the list cost trees will be formed? So this is formed based on the Dijkstra algorithm. So the linked state routing is actually following the Dijkstra algorithm in finding the least cost between every node available. So now we can look on the algorithm. Here the node chooses one node that is as the root, and from this root it will try to develop a tree. So how it will develop the tree means, from its root node it will first link one neighbor node, next again it will link another neighbor node. So each neighbor node will be made as a link based on its lowest value, that is a link cost. So here we can say the node chooses itself as the root of the tree, creating a tree with a single node, and sets the total cost of each node based on the information in the list DB. So every node, when it is considered as a root node, it will be collecting the information from the neighbors, and based on the link cost, it will first of all it will form the link between with that node to that new node in the link. So once these all nodes are added, then finally we can able to grow the tree. So now when we look on the tree from the root, we can able to see that to reach all the nodes available from the root node, here we have this least cost. So the least cost is updated here. For example, if you consider that this is a network, and for this network A is considered as a root node, first of all it is connecting the node B with this A, because when comparable to this B and this D, the cost value to B is less. So first of all it is connecting B. Next it is connecting C as well as D. Next it is connecting E, that is it is bringing to the link of this A. So the tree starts from the root node A, and thus by checking the least value of the link, it will be forming the tree, and finally the new tree will be created. So this is a concept we need to understand from the linked state routing in growing the least cost tree, and finally determining a very reliable way of communication with Dijkstra algorithm. So that's all in this class today.